Welcome. In this video, we're going to dive into selection trees, a powerful data structure that can make searching and selection tasks more. Section 1. What is a selection tree? A selection tree is a type of binary tree used to efficiently find the kth smallest or kth largest element from a set of elements. It's called a selection tree because it allows us to select the kth element efficiently, often in a way that's faster than a standard linear search. Think of it as a way to organize your data in a hierarchical structure that makes selection of elements based on their relative size much quicker. Imagine you have an array of numbers, 12, 7, 9, 3, 8, 4, 5. A selection tree organizes these numbers in a way that helps you select, for example, the fifth smallest number much faster than sorting the entire array, efficient. We'll cover what a selection tree is, how it works, and explore some of its key applications. So let's get started. How does a selection tree work? Here's how a selection tree works. Build the tree. Start with the elements in an array. In a typical selection tree, you'll arrange the elements in a complete binary tree structure. Each internal node of the tree holds the kth smallest or largest value of its subtree. Leaf nodes hold the actual elements from the array. Navigate the tree. When you want to find the kth smallest element, you start at the root of the tree. The root node will tell you the kth smallest element from the entire dataset. You then compare the value you're looking for to the values stored in the tree's nodes, navigating down the tree until you reach the desired element. Efficient searching. The key advantage is that you don't need to search through the entire dataset. The tree structure helps narrow down the search space, allowing you to find the kth element faster than you would by sorting the entire list. Time complexity. Now, let's talk about greater than efficiency. The time complexity of using a selection tree for finding the kth element is O log n, where n is the number of elements. This is because you're essentially narrowing down your search with each comparison, cutting the problem size in half at every level of the tree. In contrast, sorting the entire array would take O n log n time, and a linear search would take O n time. So, for large datasets, the selection tree can save a lot of time by reducing the number of comparisons. Section 4. Applications of selection trees. Scene 5. Transition with examples of different applications. Narrator. On-screen text. Applications of selection trees. Now, let's take a look at some of the most common applications where selection trees really shine. 1. Kth smallest, largest element search. One of the main applications of the selection tree is in efficiently finding the kth smallest or kth largest element from a dataset. This is especially useful in problems like 1. Ranked queries. For example, finding the fifth smallest salary in a list of employee salaries. 2. Median finding. The kth smallest element can be used to find the median in an unsorted list by searching for the middle element, or the two middle elements in an even length list. Selection trees are very useful in these scenarios because they can reduce the search time compared to sorting the entire list. In situations where new data is continuously arriving and you need to keep track of the kth smallest or largest element at any point in time, selection trees come to the rescue. 1. Real-time systems. For example, in a live streaming service, you might want to always know the kth highest user rating in real time. 2. Dynamic selection. As new data points come in, the selection tree allows you to quickly update the selection without having to reprocess the entire dataset. 3. K-way merging. On-screen text. K-way merging. Selection trees can be used for K-way merging, a technique where multiple sorted lists are merged into one. For instance, if you have several sorted data streams and you want to merge them into one sorted list while maintaining the ability to quickly select the kth smallest or largest element, a selection tree can be used to speed up the process. In this case, you maintain a tree where each leaf node holds the smallest element from one of the lists, and internal nodes help determine which elements to merge next, efficiently providing access to the kth element. 4. Database queries. Database queries. Selection trees are also useful in database management systems where you often need to perform range queries or find the KTH element in a dataset. For instance, 1. SQL queries. If you want to find the nth highest salary or the top K products based on sales, selection trees can optimize the process by selecting the KTH element from a dataset quickly. 2. Indexing. Databases use data structures like selection trees to index values and perform fast queries for KTH smallest or largest data efficiently. Section 5. Advantages and limitations. Scene 10. Animation showing the pros and cons of selection trees. Narrator. On-screen text. Advantages and limitations of selection trees. Let's quickly summarize the advantages and limitations of selection trees. Advantages. 1. Efficient selection. Quickly finding the KTH smallest or largest element. 2. Reduced time complexity. O log n for searching and selection, compared to O and log n for sorting. 3. Online updates. Can handle continuous data streams and dynamic selection. Limitations. 1. Space complexity. Requires additional space for storing the tree structure. 2. Construction time. Building the tree can take time, though it's still efficient compared to other approaches like sorting the entire dataset. In this video, we explored the selection tree, a powerful tool for efficiently finding the KTH smallest or largest element in a dataset. We also discussed its applications in real-time systems, database queries, K-way merging, and more. Whether you're working with streaming data or large datasets, the selection tree can be a valuable structure to help you make faster, more efficient selections. Thanks for watching. If you found this video helpful, be sure to like, share, and subscribe for more content on data structures and algorithms. See you in the next video.